IQ online classes. So in our previous videos we did KVL. So in this video we're going to do KCL, which is Kirchhoff's current law. Okay. Kirchhoff's current law. So this one says that the sum of the currents meeting at a junction junction or node is equal to 0. So Kirchhoff's law or Kirchhoff's current law says that the sum of the currents meeting at a junction or node is equal to 0. So meaning the incoming currents is equal to the outgoing currents. So meaning incoming currents is equal to outgoing current. Okay, so in simple terms it means incoming currents is equal to the what? Outgoing currents. That's what we mean. And again, there are certain things that we need to understand here. So okay. So here, when this positive terminal of the battery is connected to the negative terminal of the battery, so meaning here we're talking about the voltage of what? Talking about positive, right? Okay. So in a case whereby this positive be connected again to another positive terminal here, so here to what? Negative. So these are the basics that we need to understand. So when a positive terminal of the battery is connected to a negative terminal of the battery, so we're talking about meaning voltage there will be positive, but when a positive is connected to a positive, there automatically will be negative. So these are certain things that you need to understand when you're dealing with KCL. Okay. And again, the other thing that you need to understand is Ohm's law. So know that according to Ohm's law, voltage is direct proportion to current and resistor there. Okay. But here, because we're doing with current, so we can make here current the subject of formula. Say current is equals to voltage over what? Over resistor. Okay. Let's try to analyze a simple circuit to me using nodal analysis. So I think of this circuit here, you have this circuit here. Okay. Let's try to analyze this circuit here. Okay. So now, according to the Kirchhoff's current source, say the sum of the currents meeting at a junction or node is equal to what? 0. But in this case, when you're not given the directions of the currents there, always assume that they are leaving the node. So when you're not giving the direction of the currents there, assume they are what? They are leaving the node. Let's say this is the node here. Let's say this is VA. And because we're not given the direction of the currents, we assume that they are leaving the node. So say this one, and this one. Okay? So let's say this is I1, I2, and I3 there. Okay? I1, I2, and I3 there. Okay? So meaning, according to Kirchhoff's currents law, we say the sum of the currents meeting at a junction or node is equal to 0. So meaning the incoming currents should be equal to the outgoing currents. So in this case, say, because they are all leaving, say I1 plus, they should give us 0. Okay. So in this case, meaning should give us 0 here. Okay. But we understand what is the formula for finding current. So note, the formula for finding current is voltage over what? Over resistance. Voltage over what? Over resistance there. Okay. Then again, I made mention of this. When a positive terminal of the battery is connected to a negative terminal of the battery, so meaning there was what? The positive voltage there. So meaning to be positive. So in this case, let's start from here. So here I'm moving from the higher potential to the higher potential here. So from the higher potential to the higher potential, positive to positive, meaning here we will expect a negative. So I'll go V to be VA. So say VA minus, okay? Because now I'm moving from higher potential to higher potential, minus, this is 2, divided by, what's the resistance there, which is what? Which is 3, okay? Then we move to I2 plus, okay? Plus, so now, let's move to I2 here, this is I2 here, okay? So I2 here, we move from the higher potential to the lower potential, meaning the positive terminal of the battery is connected to the negative terminal of the battery, meaning there are what? The positive. So it will be VA plus 1 over, what's the resistor there? Which is what? 4. Okay? So we go to the third one, say plus 6, then we go to I3. Okay? Let's go to I3 here. This is I3 here. Okay. So here, this positive terminal of the battery connected to a positive terminal of the battery. So meaning there we expect what? A negative. So in this case it will be VA minus this 3 over, which is this I'm talking about, over 6 is equals to what? Is equals to 0. Using Kirchhoff's current law. Okay. So from there you can do the simple mathematics and you can easily find this VA. Just simple mathematics. If you want, you can find the common denominator here. You do your simple mathematics. You can use another mathematics, which is the pure derived mathematics. You find VA. Otherwise, this is how you make these equations using the Kirchhoff's current law. So the most important thing that you need to understand are these simple basics. When a positive terminal is connected to a negative terminal, we expect a positive. So when you are moving from high potential to high potential, so we expect to have a negative there. So these are simple things that you need to understand and Ohm's law. Then you can make that equation and find the answers. Okay. Let's try to do maybe a circuit which is a little bit complicated, or maybe we do it in the next video. Okay. So thank you. See you in the next video.